Now that we've turned up our NEs and our network using the NMS, we've now got our system up and running with our topology available to the NMS as well. All of our alarms for each node are available to NMS. The NTP has been set for our network. And so let's get a review of our map. This is our network. It's up and running. And I've currently plugged in an OSA into this EDFA, the one at 1.7 of Site 1. That OSA is telling us that my channels are now equalized at that point. So the channels that are coming in from here across these two ROADMs and here across these two ROADMs landing at this EDFA are present. And they are equalized. These are our wavelengths and our frequencies and our current power levels. Very, very equalized. So what we're going to need to do now is what's called build PTPs. We need to let the NCU, or the brain of each R7, know how each card is physically connected to each other card within our shelves. So each of these lines represent those physical connections, but now I have to actually let the NCU know where each of these lines are. To build PTPs in the NMS, well, we're going to need to launch the NMS. And so I'll go ahead and get that cranking up in order to get a connection from each of the cards from one to the next. Now there are some basic rules that we need to keep in mind. Every build for a PTP is from the transmit direction. If you build a two-way PTP, you're simply building two one-ways at a time. So one in this direction and then one from the other direction. From this card to this card and vice versa. Loops have to be accounted for. Second stage of an EDFA includes a loop hook here. That has to be accounted for as well. Anytime we do a PTP for a device that's not technically in a card slot like a 40 CSM, then we have to do it relative to the position of how it's connected to the shelf. So then our PTP will contain the syntax that includes that part name. Or in the case of a card that's plugged in separately, as a PSCU card would be, the card and slot relative to the 40 CSM. Let's get building. So I'm going to need to build for each one of these sets of connections. Now from the NM, we go to that node. We open up the element manager. And I'll bring the map up in the background here. And we'll start this build process. Right click. Then I don't select PTP table. Instead, select physical connections. We create, and let's say we start with the OSCM. Well, we've already done the OSCM. So let's look for the connections that are coming from the cards up. So 113 network. It's a client channel drop, therefore it's a two-way. Not visible. So let's go out, let's go back in. Whenever there's anything missing there, it means that for whatever reason the AID is not present. So we're going to have to go after that AID. In this case, the AID would be for the 40 CSM. So let's make certain that our 40 CSM has been created. The 40 CSM here is attached to the PSCU built into the 9HU shelf. If that's the case, then we need to go to where that connection would be housed. That would be in the CEM module of the shelf. Then we need to locate the interface that would be connected to that point. That would be FCU1 right here. So we right click, I'm not getting a response from the shelf. Here we are. So slight error here. It's not in this section, it's at CEM itself. Create. One. Next. Next. Finish. Now we have that interface available. We go down, we should see the creation of that 40 CSM now. I'll collapse it and I'll reopen it. Let's look for that connection. I closed the element manager and reopened it, and now we have that option that we were looking for a few seconds ago. We've now successfully brought in that 40 CSM. So let's try again. C4 DC1. And so the connection that I just built was this connection right here. Next connection would be this guy right here. 118 network going to the 40 CSM at D02, which is C1. Then we're looking at 17 network west going to the 40 CSM. 111 network connected to a 4 CSM. At 115. Now the client interface of a WCC, that's 18 client, going to the 2 p.m. at 110, 110 network west. That completes Site 1 for its PTPs. Then we move on to Site 2. Looks like we've got a typo on the name and number here. Not a good thing. I need to review the node just a brief moment to find out which is the correct one. After getting a look at the actual physical layout here, this should actually say 2.3, not 2.11. So I found where the mistake in the drawing is. So let's get that correction in place for our PTPs. So 215 network should go to 2.3. So this is incorrect. 2.11 network is correct. So 215 network should go to 2.3C4. What that means is 214 network should go to 211 C2. So these two are now out of the way. Now we need the interconnect between 2.3 network and the ROADM number 2. So 2.3 network, the position of ROADM number 2 at its C2 port. ROADM number 2 is on the first shelf. So 2.3 network goes to 111 network. Or I'm sorry, 111 client port 2. So there that is. Between the ROADMs, 111 client port 3 to 27 client port 2. To 7 client port 1 to 15 client port 3. So now all these connections are accounted for. We need our EDFAs to be accounted for now. Oh yeah, and between the ROADMs as well. 15 client 2 going to 111 client 1. That's this connection here. And so now 15 network to 131. 131 to the OSFM card at 11 upgrade. Coming in from 11 upgrade, going down to 114.1 or 141. 142 to 142. That would be the loop unto itself here. 141 coming back to my ROADM at 111 network or 15 network. So there's both these EDFAs. Now I have to do the other side, the post amp and the preamp. So starting from 111 network, we go to 117.1, then from 117.2 to 117.2, and then finally from 117.1 to the OSFM card at 118 upgrade. Then from 118 upgrade to 116.1, 116.2 to 116.2, then 116.1 back to the ROADM at 111 network. So this should be all of our PTPs for this shelf. And so then we move on to site 3. Alrighty, I think this time I'm going to start with the EDFAs. All EDFA connections are one way. OSFM upgrade going down to 141, 142 to 142, and 141 down to the ROADM at 15 network. Passing right through, go to the ROADM at slot 12, 112 network to 116.1, and from 116.1 to the OSFM card at 118 upgrade. Coming back in reverse, 118 upgrade, going to 117.1, 117.2 to 117.2, loop onto itself, then 117.1, going to the ROADM 112 network. Between the ROADMs, we have 1.5 upgrade and 112 upgrade. It's a two-way. And then from 1.5 network, going to 131, then 131 out to the OSFM upgrade. Now dropping our client drops from those ROADMs, so they're two-way. So 1.5 client goes down to the 4 CSM card at 115 network. That's this connection here. 112 client drops to the 40 CSM at its network interface. This connection here. So now we need to get our client cards. So then we dig further down and we see 19 network goes to our 4 CSM at 115. That'll be the first WCC. Now the second WCC is from 1.8 network going to the 40 CSM at client 1. So this is done and this is done. Now the client from each of those respective WCC cards. So 19 client goes to 110 network west. 18 client goes to 110 network east. So now I've counted these two lines here. Now I have the WCC card to be concerned with. That'll be 17 network west and network east. 17 network west goes to my 4 CSM at C4. And my network east of 17 goes to my 40 CSM at C12. There it is. So we have effectively and efficiently created all of our PTPs for this node and for this network. Now what this has done is giving us the capability of viewing this information. So now that I've established this build within this box for my PTPs, I can now go to this screen here. I'll right click, and let's say I want to track a channel coming in. Let's say D02 as it's coming in from the network. Well, that would be OL1 of this node. So I'll right click, then I find node span channel trace. So node channel trace, and I look for that OL that I'm going to be selecting. So OL1 is in the signal coming in from OL1, and on the track channel for D02. The frequency for that one is 195.90. So D02 is 195.90. There's the flow. This flow is only known by the NCU because of the PTPs that I just completed. Given this information, I want to know what my light level is for each of this as this channel propagates. Now I see my light levels as they follow the path into this node. The 1s and 2s are directions. So coming in from OL1, aka from this side, so coming in from this span, I'm looking at D02 as it comes in and lands on the node. So then I'm coming in from OL1, outside line or optical line. It's brought in. Now because it's a passive device, there's no information here. It flows through and it lands on my OSFM card at its network interface. From the upgrade port, it's handed down to that EDFA. The EDFA says that it's receiving that channel, and it's going to receive that channel at a neg 14.9. So right here, D02 is 14.9, neg 14.9. It goes across that EDFA to the second stage, means that across this hook here, it gets amped up to a positive 2.2. It's received at that side of it at a 2.1. So there's 0.1 attenuation between here and here. Out of the other end of that, it's spit out of the front end of this one, which is stage 1, at a positive 15 dB. In turn, it goes from that to land on the ROADM at a positive 14.8 dB. And so it's hitting at that positive 14.8 dB. Hitting it at that point, it's got to go through the ROADM and be processed, etc. But then that ROADM will in turn hand that channel down to a client port. That port is unmonitored, hence there's no information there for that port. It hits a 4CSM, which is another passive device, without a monitor either. And so from that 4CSM, it finally gets handed down to the actual channel card itself. That channel card is a WCC card. D02 is making it all the way through at a neg 12.7 dB. Notice that at this point, the ones stop and we start with our twos. So now we're looking at what's coming in and then what's going out. In the opposing direction, leaving from that landing point. So coming in from the optical line, we've tracked that channel as it finally landed on my WCC card. Actually, WCC card over here. D02, that was the channel we were tracking. That channel was 195.90. So we see the light level as it's landing. We know it's landing here at a neg 12.7. But then we want to know what's it leaving at to get away. And so that card is telling us that it's transmitting that channel at a neg 1.9. So transmitting out, once again, the 4CSM is passive. It goes from that and it hits the client interface of that ROADM. When it hits the client interface of that ROADM, the ROADM it's telling me that the average power per channel hitting that point would be a 1.7 dB, but that it's currently not monitoring that light as it's leaving. And so the ROADM is not really giving us any information there. However, as it goes through that ROADM, is processed by that ROADM, it's telling us that it's now spitting that channel out of that ROADM at a neg 16.9 dB as its power per channel, average being a neg 9.3. So neg 16.9, it's leaving the network interface of that ROADM for that channel. Now this would be equalized considering that the set point of that ROADM for its equalization is actually a neg 16. So neg 16.9 is within the offset of 1 dB. So this is leaving that ROADM's network interface as a transmit. In turn, it's going across and it's landing at that EDFA. Actually, this is an error. I actually mean that's 9.3 that it's leaving at. At that 9.3, it takes an attenuation hit between here and here. And so it's hitting that EDFA at a neg 12.6. It hits that EDFA, crosses that EDFA, and crossing that EDFA, we are getting amplified from a neg 12.6 to a positive 7.7. It's a single stage EDFA, so this is what's received, and this is what's coming out of the door. At a positive 7.7, it's leaving that EDFA, and we at least know that channel is getting to the network at a positive 7.7. From here, it enters the upgrade port of the OSFM, and is processed and then sent out of the network interface of the OSFM as it goes to the next hop. So I know what I'm getting and I know what I'm sending. This is the basic graph information of that same signal flow. From the optical line to the OSFM card, to the EDFA, to the ROADM, to the 4CSM, to the WCC card itself, and as it's leaving from the WCC card to the 4CSM, to the ROADM, to that EDFA, and out the door. So that's how our signal flow works. This is called the node span channel trace, valuable tool for troubleshooting once we've created our PTPs. This is the front door of control plane.